In today's lesson, we are going to look at section 2.8 and discuss the math and the random class. In order to do that, let's first talk about what it means to have a class library and a package. So as we've talked about in class, we will have a class file that describes a class of code. And we will get more into this through the next week or two, but there are bundles of classes that are grouped into what's called a package. So a library is a collection of classes that we can use when developing our programs. And there are many libraries that are already created by Java and are available for our use. The Java standard class library is already included by default whenever we run a program within a development environment such as BlueJ or Eclipse. There are other classes that are available to us but that are not automatically opened up, and that's when we will import them. Two classes that we have already used quite a bit that were included for us are the system and the string library. And other class libraries can be obtained in other ways by other third parties, or you can even create your own libraries. Now, the packages are essentially a collection of class files, and we have already seen the AWT package when we were doing our graphics, and today we are going to see the util package when we do the random class. So we'll see all different types of packages, and a lot of times if you need to use them, you will know because you'll get an error message in your code because it won't recognize a class name. And if it doesn't recognize a class name, it means that you need to import that necessary package so that it knows what it is. All right, so how do we import? Well, in order to do an import statement, we need to use the keyword import, and then we just have to tell it where to find that class. Now, there's two ways that we can do this. One way is we can specify a specific class file. So in this case, the util package has lots and lots and lots of classes. And if you were to Google it in the API, you could find all of the classes that are located in java.util. But if we only need one, then we should just import the one. There's no reason to open all of them if we don't need them. However, sometimes you'll be working with a lot of classes within the same package, and in that case, it makes more sense to just do the dot asterisk, so that way it selects all classes in that package. It's important to note that you will never be asked to memorize these statements or the different packages that classes are located within. That's not something that you need to worry about. The classes of java.lang are already imported automatically, and random, which we're going to learn about today, is in part of the java.util package. Okay, so let's talk about the random class. The random class is used for us to generate random numbers. Now, it is said that the random class uses a pseudo-random number generator, and that's because it's not exactly random, but it sure appears that way. If you were to generate, hundreds of thousands of numbers, you would start to see a pattern among them, but for most purposes, the random class does the job for generating a random number. Now, there are two methods that we will expect you to know, next double and next int. And essentially what these do is these generate another random number. Similarly to how your graphing calculator might generate a random number, or if you had an app that generated a random number, it's the same way. And the different name, next int or next double, tells you what data type the random number will be. Now, if we're working with a double, that is a number type that has a decimal place, then this will generate a number between 0 and 1. Now, we are using interval notation here. Just like we see in math class, the bracket includes and the parenthesis excludes. So what does that mean? That means for this interval here, I start at 0.0 and I go up to but do not include the 1.0. Now, next int, this method takes a parameter, and that parameter tells you the maximum number, the maximum integer to go up to but to not include. Now, in the next couple slides, we'll see a few examples of how to implement these methods. So you'll notice here on this practice file, we have not only the import statement up here, but we also have our class header. And then after our class header, we see our method header. And we've talked about this, but just a reminder, within Java, the main method is the one that is executed. It's the standard method that we run to run our program. And when you're doing small tester projects like this, you just kind of put all your code within main. Pretty soon we're going to start doing larger projects and we will break up into more files. All right, so this line of code right here creates a new random object. The first word random is the class name. Rand is the variable name. And then I'm saying that this is equal to a new random object. And random right here, this is the constructor. And this is how I build the random object. And we're going to talk more about building objects over the next few days. This should remind us of when we made new JButtons or JLabels or JPanels. We always had to say class name, variable name equals new, and then call the constructor. So now that I've created this random object, this is essentially allowing me to generate random numbers. So here, the random object that I created, RND, is going to invoke the method nextInt. And notice that the same method can make multiple method calls. I have to have a method I have to have an object to invoke a method. And that's how this dot notation works. So recall that the nextInt generates a range of integers. And so nextInt 5 generates a range of integers starting at 0 and up to and not including 5. So another way we could represent this is 0, 4 with the brackets. Now, I don't always want my range of numbers to start at 0. So if I don't want my range of numbers to start at 0, I can have an offset number, and then I can add that to the value from the random number generator. And so that ends up giving me a range of numbers from the starting point to this interval plus the starting point. And that's how I end up getting this range of numbers 3 to 7. Now, when working with next double, this is going to generate a number between 0.0 and 1.0. So in this case, I often want to extend the range of the numbers. So if I want to extend the range of the numbers, I have to multiply by the method call. So this will take my decimal, and then I'm going to multiply it to be larger. So in this case, by multiplying by 5, I am essentially taking 5 and multiplying it by this interval. And that's how I get 0 to 5. Now, just like with the integers, if I want to offset the starting point, then I'm going to go ahead and this should be a plus sign right here. I'm going to go ahead and add a number to it, and then that will be from the starting point to the starting point plus the range gives me my last value. So this should be a plus sign. Please correct your notes. I thought I caught that. All right, next we're going to talk about the math class. Now, the math class is a little bit different from the random number class. The math class includes several things. It includes, first of all, common math constants, such as pi, and common math methods. Now, what's different about the math class is that these constants and methods are static. And we'll talk more about static in future days, but essentially what static means is that you don't need an object to call the methods. Instead, we call them through the class name. So we put the class name dot the method name. And that's similar to how we invoke the print line. We say system.out. We're calling it in a different way there. Okay, so here I've got a couple examples of our math class. In all of these cases, they're just going to print out different things. So this right here, the first one will just print the math constant of pi. The second one is going to print the square root of 10. The next method will evaluate the cosine of pi halves. Now, for those of you that have learned trig before, the trig methods all require that the parameters are in radians. Now, if you're currently taking trig, you might be wondering what the heck is a radian. You'll learn about that soon. For right now, just know that if you were to put cosine of 90 and expect it to give you 0, it would not equal 0 because this input is not degrees. It is expecting radians, which is just a different unit of angle measure. ABS is your absolute value, so that would do the absolute value of -5, and POW is going to give you the power feature, so 2 to the 3rd power. There is a handout on Schoology called Math Random Classes that just has a few more examples of these two classes and their methods. All right, so the last thing that we're going to talk about is what's called a class method. And class methods or static methods are what we see when we talk about the math class. And essentially what's unique about these methods is that these static methods provide specific functions that do not require an object to function. So the concept of square rooting a number is totally independent of what number it's square rooting. And when we have these methods or these functions that always perform a specific way, regardless of what kind of number called them, then that is what we are calling class methods. And as I said, we will develop this concept more in coming weeks, but basically what we need to know is that class methods are, they're going to be invoked through the class name. Okay, they are invoked through the class name. All right, that's it for our video. Tomorrow in class, we'll run through these concepts a little bit more, and then we will do some practice coding, and we will also look at what is called the Java API, and we will learn how to access that. All right, that is all for today.